All right, we're going to quickly review how to divide rational expressions. Dividing rational expressions, which is found in section 12.2, we have again covered in sections 8.1 through 8.5. Several times we've gone over those. So first of all, remember that you multiply by the reciprocal, just as you do with fractions, right? And it's the first number here multiplied by this, the reciprocal of this second number, the divisor. So dividend multiplied by the reciprocal of the divisor. Then we multiply as we were just learning before. And multiplication, remember, is factor, cancel, and then simplify by multiplying it out. So let's go ahead and take a look at this first example. So just a second, I'm going to write this down and then we'll factor. All right, so the first thing that we do is that we want to multiply by the reciprocal. Now, if this is a first time around, I highly recommend that you actually physically just write out multiply by the reciprocal. But we're going to do two separate steps here, and this is a little bit more advanced move. So the first thing I'm going to do is I'm going to factor out my first one here, which is my dividend, and this is the leading coefficient, not 1, so I need the factors of 2 that are going to sum to a 1. So I have a 2x here, and I have an x here, and I'm going to have 1s in each of these positions, and I need to make a -2 and a +1. Remember, my outsides give me a -2 and my insides give me a +1. And now I'm going to multiply this by, and then I'm going to take this one and I'm going to put here in the numerator. I'm going to factor it out. So I need the factors of 2 that sum to 3. So I have an x and a 2 and an x with a 1. And this time around I need a -3, so these are both negatives. And then this one is going to get put down in the denominator. I'm taking the reciprocal of this. And so this is a GCF first of all. So factoring that GCF, I see it looks like 3 times x squared minus 1, and that would be a binomial difference, and those are squares, so it's a difference of two perfect squares. So I'm going to write down that GCF, and then an x plus a 1 and an x minus a 1 because I need the product of conjugates there. So I have a minus a 1 and a plus a 1. Now that I have everything factored out, I cancel. So I'm going to change to a different colored pen, and we have an x plus 1 here, and it can go with one of those x plus 1s there. I have an x minus 1 here, and it can go with one of those down there. And then that's it. That's all I have. So now I can rewrite this as a simplified version. So I have an x minus 2 left in the numerator, and then in the denominator I have 3 times 2x plus 1, and then times an x minus 1. Now remember, depending upon your type of book, you may see it just left as that, and in our text, Lehman's text, he is leaving it like that because we are in algebra and intermediate algebra text. But in a basic algebra text, what they would usually do is they would usually multiply out these two right here. So what you would see is you would see a 2x squared, and then a minus an x, and then a minus a 1, and then that gets multiplied by 3, so you would see this being rewritten as x minus 2 over 6x squared minus 3x minus 3. And that's how they would rewrite it, because they like to see that factored out or written out completely as a product. But again, pay attention to your particular book. Now what I would like to see you do is I would like you to do part B and part C on your own, and then I'll come back and do those as well a little bit later. So these two problems, and then we can come back on those.